Let's see. So we've been working since August on this robot, and
But we've been working since like September.
yeah, so we didn't really get into the group because we had some lab partner issues.
Yeah.
They kind of dropped the class, and nobody figured out about it until like a month later. But it started out a little bit rough. The Bluetooth function never actually worked throughout the duration of the project. His thing didn't have Bluetooth, and then of course we got the program onto his laptop a little bit late. But after that, we pretty much breezed through the first few labs. And
Clockwork.
when we got to I think it was lab 4 with the sensors, then apparently the drivers weren't updated, and we didn't know that at first, so it took a little bit of time to get that straightened out. And get the project lab hours kind of didn't really fit our schedule, so it's hard to get into the lab every week when you got a class, and then get out. There's like 5 minutes left in the lab time, so that was a big problem to work around. So most of the time we've been working pretty late at night on these projects.
Well, mostly we're building the robot. We're building the Segway robot actually. And it took me a couple of days to actually find a design that I could really work with, that I felt would work. And we stuck with it throughout the end of the project. We felt like it was the best design to go with. And as far as programming, we already had in mind the idea of how the program should look. We had something to base it off of from the previous labs that we did during the course of this class. And in the end, it didn't. I don't want to say it didn't work. It worked for about 5 seconds. It balanced itself.
But of course, the motors, the batteries might be low, or it's just the motors aren't powerful enough. But it balances. But once it leans over past a certain point, the motor can't pick up the weight, and so it flops over eventually.
And so we put the wheel in the back as that just saying that if it hits the wheel, it was basically going to fall over anyway. So the wheel is just there to let us know, it was going to fall over right there. And another problem was the sensor was in the front, so if it leaned too far forward, it will hit the sensor, and then we will also know that it was going to fall over.
It's been a long process. The coding was pretty much simple. It's basically a while loop with 2 if statements saying if the light sensor reads a value that's brighter from the LED reflecting back into it, then it's leaning forward, so you increase the motor rotation forwards. If it's darker, because the light sensor can't pick up its own light after it leans back, then set the reverse function to work, and so it counteracts the balance of it. And that's just pretty much an infinite loop, so that it just keeps repeating this sequence over and over again. And what it does at the beginning is it takes value for the light sensor, and we usually balance it first and then set the program to run so it has that initial value, and it tries to maintain that value with the while loop. And once it goes over that limit, it goes forwards. Once it goes under that limit, it reverses. And that's essentially what you have to do to make it balance. The code itself, it's a good code. The code works. Of course, you have the constraints of the physical materials that you have to work with. But I think if we could have a more powerful motor, then it would certainly work, because the motor response time here is not as fast as we would have liked it to be.
Maybe also if I had some bigger wheels. Some bigger wheels might have helped it also.
We also tried a few things with changing around the moment of inertia on it. We extended the arms out a little bit, added a little bit more mass to the top of it, and tried to see if we could get to slow down its rotational motion. But it helped after the first time we did it. Then it actually had balance for one of its first times, and it started getting better after they tried a few experiments, added some more different mass along the robot, and added a safety wheel eventually, because we didn't want it to keep flipping over, hitting the table until something just eventually broke off.
Talking about gyroscopes.
Oh yeah, gyroscope. We actually had an idea to take the motor, and instead of using the motor, the third motor, as the person just for cosmetics, then we were going to take it and try to attach it horizontally so that we could connect maybe a large wheel or some kind of rotating object so that we could have the motor running at 100% to get the centrifugal force, so hopefully we get a gyroscopic effect so that it might help bounce it even more. And then of course the wheels working to self-correct the tilt of the robot. And so we were hoping that a gyroscope on this Segway might help to balance it as well. But it didn't really work out as well because we don't really have a large enough flywheel to make it work.
And then I don't feel like the project was a failure. I just felt like due to certain limitations, we weren't able to get it to work. That's
for the most part, it's a good project to work with. It's definitely a fun experience. One of the best moments, of course, came when we got the program to work in maybe 25 lines. After seeing some of these codes that are over 200 lines long, and you write like 25 lines on it, and the thing works for the first time. But that's that Segway project.
Oops. Ready?
That's good. Hard, man.
Yeah, come back up there. Let me know. Stop,
Huh? Yeah. It's probably self-balancing. For the most part, I mean, it can do it, but like the motor responds so slow. You have to just.
I used to do it. I have the old one.
The yellow?
Yeah, the yellow one. It's really cool though.
Damn, looking like.
so too. You should turn it off. You can turn it off.
Like going forward, like almost falls over it. Which means it's falling back a problem. I mean, for the most part, it kind of knows how to. This is probably the best project.
Yeah. Alright. You got 6 minutes. You can turn it off.